Welcome back to my channel. Today we are in a new university in a new city in China. Today we are visiting Nankai University in Tianjin, one of China's top academic institutions with a strong reputation in research and innovation. So the university was established in 1919. Nankai has long been a center of excellence in environmental sciences and engineering, so it's very known for that. And we will be spending the next 2 days at the College of Environmental Science and Engineering. We will meet Professor Zhi Cao. We will have an interview with him and with his team. We will tour the campus together, have lunch, attend 2 guest lectures that I'm going to give, and participate in research seminars, all while engaging with the PhD students and researchers working on some exciting environmental projects like the use of timber in the built environment, the modeling of carbon emissions, reduction of carbon emissions, and other exciting topics related to road engineering. So join me as we explore the university, take part of the discussion, and learn more about this cutting-edge work being done here in this environmental sustainability and engineering. And let's dive in.
My name is Zhi Cao, so my first name Zhi, my family name Cao. I'm a professor working at Nankai University. The name of my faculty is Faculty of Environmental Science and Engineering. I'm working a lot with environmental scientists, also environmental engineers. We are working on topics related to sustainability using knowledge and engineering principles from different engineering disciplines. And our community is called industrial ecology. So we are industrial, ecologists, and we're working for sustainability, and we're also working for other important initiatives such as circular economy. We want to understand what is the reason for why our society, why our world is becoming unsustainable, and what are reasons behind, and what is the mechanism behind this unsustainable transition, like the great acceleration process. And then more importantly, we also want to find out what are the solutions, to address these sustainability issues, and do we face any trade-offs, or can we find any synergies among those solutions? So we want to use a systems approach to addressing all those issues, to find an answer for those issues. In the domain of industrial ecology, we have multiple and important tools. The first one is material flow analysis, which is the tool I use very often. And there's another tool which is called life cycle assessment. I believe a lot of industrial ecologists have been working a lot with life cycle assessment. We also have some, on-demand tools. For example, we also applied a method like urban weather generator, or climate change downscaling tools to help our research. Yeah. So
Great.
the main tools are material flow analysis (MFA) and life cycle assessment (LCA). A lot of our studies are actually future-oriented studies. So which means we use scenario analysis. Sometimes it could be very difficult to really validate. But of course we try to to validate the robustness of our study by conducting uncertainty or sensitivity analysis. I think this is a very common practice in our field, also maybe in other fields. In our university, we do have a joint program with Glasgow University, the UK one. Yeah, and also we do have a strong international office supporting exchange students for masters or even bachelors or PhDs. So we are very happy to to host international students, bachelor level, master level, PhD level, and also in our lab since we have people with a lot of people with international backgrounds, so we would love to have exchange students. And daily life-wise, I think in general in our campus, we do have a very friendly environment. Let's say international friendly environment for exchange students. In general, I think the internalization of China's university is getting better over time. Of course, compared to 20 years ago, probably you may have difficulties at that time, but now I think everything is getting more digitalized, also more internationalized. Yeah, that's totally possible, because I know some of the programs, they already you can defend in English, you can write your thesis in English. For example, the joint program with Glasgow, there you have to write your master thesis in English. So we already have the whole facility to support exchange students working in English, deliver your final product in English.
Very good.
I really like this proverb, which is like 天道酬勤. It means if you work hard, you will get what you need or what you want. 天道酬勤. It means if you work hard, you will eventually succeed. Right. Thank you.
After wrapping up my interview with Professor Cao, we moved straight into the seminar here at Nankai University. I opened with a presentation on urban heat mitigation and adaptation strategies, practical ways cities can respond to the growing impacts of climate change. Then the spotlight shifted to the PhD students and the collaborator and researcher at Professor Cao's lab. They shared their research, including a fascinating talk on the role of urban green spaces in reducing the urban heat island effect. It was an inspiring exchange, linking theory with real solutions for more resilient cities. So we left the College of Environmental Science and Engineering, heading to the outdoor labs and to the university restaurant. Walking through Nankai Zinan campus, you feel that there is a balance between an ecological park and the university. Wide green corridors, a lot of lakes, and restored wetlands create a living landscape that cools the campus and supports biodiversity. These nature zones aren't just for beauty, they are also functional for the university's commitment to ecology, resilience, and sustainable livings. There are a lot of sensors all over the place and different research experiments running on campus. It was a very interesting setting to have an idea about this university.
Yeah, in Wageningen we had a course on biodiversity.
Okay, we had enough block, so
Okay.
we just cut that.
Okay.
里边就有青菜啊。
And let's say a lot of cities in the global north, they are contributing a lot to certain emissions.
True.
And then thereby leading to global warming, right? But this global warming has an impact over, the world, but this impact is not equally distributed.
True.
Which means, for global north countries, they enjoy more from the urbanization, from more advanced built environments, infrastructure, and so on. But then the burden is taken by people, from the global south, or from, less privileged, communities.
While they did not contribute or even were even a significant part of the consequences. While, like what you say, the let's say global north or certain hubs in the global north, they are very responsible for these impacts. And then at the end, it's a fair word. When we say +1 degree Celsius increase, it hits the whole world,
Right.
and some areas, some islands even get completely flooded or underwater,
Right.
while they were having zero industrial infrastructure, for example.
Even within the city, you can see that some neighborhoods they are more equipped with space conditioning equipment, right? Like air conditioner or heaters. But for some within the city, for some neighborhoods, because they have less financial resource, or let's say in general social access to those space heating technology or more advanced technology, like imagine in a future with a target of achieving carbon neutral, and that means you have to upgrade your basically your HVAC system or your envelope system, and then for those community, for like those less, let's say for those poor community, they don't have access to resource.
So the problem of affordability, access, equity,
Right.
fuel poverty, or in general climate change poverty problems.
We call it energy poverty and also heat poverty.
Yeah.
I don't know. I mean, maybe this is not a better, good term, but you know what I mean. So those people are hit by the heat,
Sure.
but they don't have any measure to tackle this issue.
Yeah.
The rich, they're contributing more to the global warming, but they have more access to they have
Compensating
better,
or adaptation measures that from one side make the situation worse but make their life more comfortable.
right.
So if we don't break this circle or this cycle or this chain, it will create also a lot of social injustice, and then you can say that actually the poorer the people will
Right.
pay the bill of climate change, and the more if you're having access,
And recently, we are trying to understand. Okay, so let's say 1 additional kilogram of CO2 you emit into the air, and what is the effects on the global community for each, let's say, for each kilometer breathed.
You're trying to quantify that.
I'm trying to quantify that to
Wow.
see the unequal distribution of the burden taken by each community.
So this requires really high resolution modeling,
Right.
and that you have top down and bottom up in the same time.
Yeah. So it's like so let's say we emit 1 kilogram of CO2 into the air, and then probably we have a model that takes into this 1 additional kilogram of CO2, and then the global let's say it's a global circulation mode system will react to this 1 additional kilogram or 1 ton of CO2, and then we will try to downscale this effect to each kilogram grid, and then we see we see the spatial pattern, and we see the the inequality in this issue, and we want to say maybe this 1 kilogram CO2 emission coming from this city, but these other 10 cities are affected or are more affected by this, one additional town.
True.
So we just want to have this kind of picture.
Sure. This is very good, because then you see the balance and the unfairness. Because I think also when we say 1+ degree climate change increase or 2 degrees, it doesn't mean that it will be 1 degree in the whole world. No, some cities will have 10 degrees or 12 increase, and some others will have only 0.5 or 0.8. And this is again this kind of undistributed effect of climate change, making that some cities and people or nations, they will not feel the impacts, and others will suffer severely.
And even worse, I mean, even you have, let's say, the human comfort is not only determined by, it is not only determined by temperature. It's by the radiation. Like, I don't know if you know what I mean. Like, for example, this the TMRT is determined by
the mean radiant temperature.
Yes.
Yeah, we say always radiation, humidity, airflow, temperature, air temperature, and radiant temperature, plus metabolism and clothing.
As you said, you went to those, this rich neighborhood, you see that they have a lot of green, right? So but for those poor neighborhoods, they don't. Right? That means they have a lot of they have shading. They have more shading compared to,
and they have a better vegetation, meaning that they have better humidity rates. Maybe also they have a lower urban density, meaning that airflow can go around and inside the building, improving the comfort. Even if there's a power outage, there is injustice. So even if you cut the electricity on the whole city, let's say for any event or a lack of power demand balance, you will find the injustice in the city on the urban level. But what I find it also very interesting, and I'm already working on it, is that exactly what you're trying to do with characterizing the impact of climate change on social injustice and comfort. I'm also very interested in health. So I'm trying to focus on mortality rates in relation to the urban heat island effect, or in relation to heat waves, or any climate resilience related shocks or disruptions that can happen in the city.
At our university, or recently from the national government, we are trying to adopt the concept which is named One Health, or holistic health. This concept. So we're not only looking at heat exposure, we also want to link, let's say, the reaction, the sensitivity of different population groups to heat, and also the people's access to health, let's say, facilities
and
like
services.
hospitals and services and so on. So this is something really emerging in our domain. So we wanna really track from, let's say, emissions, and then heat, and then comfort, and then health. So you really have like a close, let's say, a holistic chain about holistic perspective of, about this whole kind of logic chain, let's say. And this is very interesting for me, and I have invested a lot, and 3 PhDs are working on this topic.
Very good.
One on its the built environment per se, like how much CO2 what are the quantities of CO2 emissions, and then how to decarbonize the residential sector or the commercial sector. And then another PhD is looking at what is the when you have this degree this increase in temperature, what is the effect? What is its effect on the urban heat islands, the thermal comfort, especially outdoor thermal comfort? Of course, I'm not expert in indoor thermal comfort, but I think probably this area we can have more collaboration.
Sure. Because we try to work to couple indoor comfort with outdoor comfort, and still it's not a seamless way of calculation, and it takes into account the mass and the radiant temperature outdoor and temperature, also weather pattern 3 days or sometimes 1 week before, because the city also stores the heat, so it's not a straightforward equation. This could be also a very good opportunity to link indoor comfort with outdoor comfort in the context of a global city or neighborhood scale. And by the way, I want you also to invite you to the Annex 97 of the International Energy Agency. It's just started in April 2025. The meeting was in Vienna with Dr. Peter Holzer. He is the operating agent. And this annex is working on resilient cooling in cities. So maybe also I will bring you in contact with him.
Sure.
And we are already in subtask B. We have, by the way, I have a PhD student from China originally, and he is working on this topic. So I think I will bring him also and link with you so that we start to see if the PhDs can do something, or we on the level of professors, we can find a paper or a common publication, because this is really relevant. And we are looking for case studies. So you work on case studies, or you stay on the level of cities or models?
I have also case studies. Like, so previously I was looking at the effect of high albedo or reflective materials or reflective surfaces. Like you just white painting. Very simple. But we find out that this is not really a good strategy. Like if you apply white painting on pavements, actually sometimes it's not good. Because taking into account of course I read some papers. I came across some papers mentioning that the white painting can reduce air temperature by really like 0 points.
Insignificant.
But of course it can reduce the pavement temperature for sure. That's like maybe 5 to 6 or even more than that. From one professor from Arizona University. I think they have a really strong team in urban heat island effect. But it's
most probably Professor David Saylor in Arizona State University, and then also Matt Santamuris in Sydney is working on that. But like you said, is right, is that if you study only the treatment or the coating or the painting as a single factor cause effect, maybe you would have good results. But when you look at the holistic or multifactorial result, it's not positive. So on the second day, one of my PhD students is going to present something on like the effect of high albedo surfaces on the TMRT. So it's not really promising. But we want to argue for so probably it is good for the durability of pavement, because if you lower the temperature of the pavement, especially for rotting resistance, rotting, right? So it's rotting is like because usually most of the pavements are made of asphalt materials, and asphalt material gets softer when temperature rises. True.
And then if we don't manage well, let's say it's too soft, then you have rotting problem, right? The cars
marking their
and then you have like
degradation, and then water, and then the vicious circle.
So you have, if you have a rotting problem, then probably the durability or the roads lifetime gets shorter. So having high albedo pavement is good for the pavement, and probably the high albedo pavement, I don't know if it is good for the surrounding buildings, because you basically reflect solar radiation
back to the buildings,
back to the onto the building walls. So
what I learned so far is that the best way is, if we will apply high albedo reflective coatings in general, it's on the roof level, but not anymore on the pedestrian level nor on the facade level, because also you create a lot of glare. So visual comfort will be very bad. And what you said is that this reflected radiation will be compensated by additional cooling loads in the buildings and reduction of the thermal comfort in the buildings. So I think we still don't have 100% conclusive and comprehensive, let's say, findings about it, but a lot of studies are indicating that we need to have a warning system. Take care. It's not the magic bullet solution.
It's definitely not. I thought it depends on the urban context. It depends on the urban morphology.
Exactly.
So we should have. I think this technology or this solution has certain
limitations.
Limitation. Also, that means certain applicable like context. Maybe like in the low rise and open.
Maybe urban.
Yeah.
I saw it working. I studied in Texas, and we were using it on the roofs, and it was like a villa neighborhoods, and it worked relatively good after we did some measurements. But again, I think once the density is too high, or there's a lot of pedestrian in the street, with the light, it's also white. Imagine we need sunglasses when it's already hot,
right?
And then everything is white.
Right. Yeah, I totally understand. So this is something we want to discuss, across cities in China. So
okay.
we have some case studies across. But,
that's good.
But it's all modeling. We don't have really like we do have some measurements in Tianjin. We just want to test out the accuracy of the model. So we are using urban weather generator.
Okay.
I don't know if you're
urban weather generator.
We don't have we do have an ambient capacity, but it's very small scale, usually.
Yeah.
But for larger scale, of course, we can go with WRF, urban climate model.
Yeah.
But WRF is just too coarse, we won't be able to have reach
very fine.
But so we go with this 1 kilometer resolution.
Mm-hmm.
So this is something in between, like ambient, you can go with like even sub-meter, resolution, and for WRF, usually you go with 10 kilometer or 20 kilometer, resolution, and that's already really computationally expensive.
Yeah.
So we find something in between, and we go with urban weather generator. Of course, the UWG is not perfect because it doesn't take into account the water body. So this is one issue with it. But now we have some interesting results which will be presented on the second day, and so
it's exactly what we are doing in Annex 97. We are doing state-of-the-art review on the latest modeling techniques, and we are listing the urban weather generator, MVMet, WRF, and some other software that we're saying they are promising. But again, every software will have limitation, and then we need to have a complementary approach to test or to
right. So this is another reason that we need to have a global database. So I'm trying to nowadays, they have so many data sets which we can use for creating, let's say, a consistent, also multi-resolution data cubes for at least for the urban canopy parameters, and that's one thing. And also the urban greenness or urban green space. So we want to have two data sets, one for urban canopy parameters, one for urban green space, because these are the two important elements for understanding the urban heat island.
So you call it cubes?
Because we have multi years, and we have this global coverage with and also we have multiple parameters. So you have to organize your data as data cubes. It's a concept from the geoscience domain. They have Earth data cubes. So it's like so imagine, so you have a remote sensing image, right? So this is you already have latitude and longitude, right? So you have X and Y, and then you have then if you have multiple years or multiple, let's say one image for 1 hour, and within year you have 8,006 something images overlapping with each other, right?
Yeah.
And then this is only for one parameter. Let's say this is only for the surface temperature, right? And the then surface temperature, and then you have like
humidity and
whatever,
radiation. And
so it's a cube.
Cool.
Right?
It's very interesting because also metaphorically it's interesting to visualize.
I want to create this kind of data set which we can make it open access, so everybody will reuse this data set for doing their own research.
True, and then maybe if we can characterize or cluster the weather to certain categories, and then you say, okay, this is close to this, and then you find that those nature-based solutions or these interventions will fit better because there is a similarity, for example.
Also, another thing we want to do is to use this large data set for data mining. So now we are facing the challenges of computation, right? For example, this model is so
heavy.
It's so heavy. So now we are trying to develop like surrogate model. I don't know if you know surrogate modeling. It's basically you use mechanistic model to you have a lot of access. You predict Y. Let's say you predict air, like the 2 meter air temperature, and then of course if you want to predict each kilometer grid for each hour across the world, if you have a strong, like let's say a server to do so, computing server to do so, you maybe you can spend 1 year or 2 years to do analysis. But we can actually develop a surrogate model based on, let's say, sampling strategy, a good sampling strategy, and machine learning models to expedite the computation while maintaining the accuracy.
Okay.
So this is called surrogate model. It's basically you know the axis, you know the y, and then the axis and the y are predicted by mechanistic models. Like it could be WRF or UWG or whatever models. Of course, with with temporal dimension.
Yeah.
And then you can use, let's say, neural network, because they're really good at or any other time series machine learning models, which are good at processing time series data. And then you can train a few models, good based on their accuracy. And then once you have these machine learning models, their prediction is very fast, like 0.1 second for one prediction. This is something we already use for the global. We have a county level residential building energy simulation for China for from 2020 to 2100.
County level.
County. So in China we have more than 2,000 counties.
Okay.
And then for each county we have a lot of vintages, like the age cohorts. And then over time, you have for each county, you have a lot of age cohorts.
That's a huge data set.
Yeah, if you use NH Plus to do the simulation, it's gonna take you 1 year, 2 years.
But talking computational capacity, we have in my lab a microstation or like a supercomputer.
Right.
We call it Scorpion, and if we need, we can get access to the supercomputer,
right,
which is available on a national level. What are the computational capacity that you have in your university or in general?
In general, I don't have access to supercomputing capacity. So this is the reason why I try to develop parallel computing or circuit model.
Okay, so that it reduces or cuts the computation time in an intelligent way without being too abstract.
Yeah, it's that, because imagine. So now I'm also collecting building level information, like this UBAM concept. So if you, let's say, imagine now we have so much information about each individual buildings, and then we are able to collect the information for, let's say, for Tianjin we have more than 1 million. I think this is my just a rough number from my head. So more than 1 million, I think.
Wow.
1 million building. And then if, let's say, if we divide Tianjin into a lot of 1 kilometer grids, and the buildings located within 1 kilometer grid, they share the same, let's say, urban climate. But then you still need to do a lot of computation, right? Even you, let's say, for these buildings, for this 1 kilometer grid, because we are always using, I think a lot of researchers are using this archetype or prototype, modeling
Archetypes.
archetypes to do the energy simulation, right? But if you divide your city into 1 kilometer grid, then your computation time would be, at least for Tianjin, you could divide Tianjin into more than 100 grids, and then that's your computation time is 100 times more. So that means you really cannot rely on like mechanistic model. Like
to be honest, I'm looking forward for China to invent the quantum computing capacities. I'm not sure how far is this going to be promising.
It's just too expensive for a group like us. So
okay.
Even let's say we do have a supercomputing center, but we need to pay. It's gonna cost us like let's say 100,000 euro per year just for doing one PhD project.
Wow!
So it's not really worth it.
So it's really cost intensive.
At least I get a big grant, and also since we do have this strategy, why not just do it in a
simple way?
Simple way, or
I fully agree. I mean, simple way, but because we hear so much a lot that quantum computing in China is going to be the next breakthrough. You have also to see that we are people outside China. We hear a lot of things, and we still don't know what is still feasible, or in an advanced stage, or maybe in an early stage.
In China we have an old saying like use a big gun to just shoot a mosquito.
That's as a scientist we should not do. So
not do that. So
okay, I think this is a good moment to have a break for the conversation, and then we build up something new. Thank you very much.
On the second day, we were back on campus and we were biking across Nankai University green and water-filled campus. Together with Professor Cao, we were discussing his major milestone in his career and how he's engaged to the International Society for Industrial Ecology. We discussed the different available pools of funding and how we can develop and contribute to cutting-edge work on climate adaptation, urban ecology and sustainable design. Moving through the green corridors and water landscapes of the campus, it was clear to me that this environment reflects the spirit of their work, rooted in ecology, forward-looking and deeply collaborative. It was a privilege to be part of this community, even for a short time. Then we continued our seminar. I had the privilege to give a lecture on Foundations of Scientific Writing and introduce my YouTube channel to the PhD students and research collaborators. We had intensive discussions and exchanges, and this visit made Nankai University for me both inspiring and unforgettable.
After 2 full days at Nankai University, I'm leaving with a deep appreciation for the energy, intellect, and collaboration happening here, from insight seminars and engaging lectures and into-depth lab discussion. The College of Environmental Science and Engineering is clearly a leader in shaping sustainable future. I've seen how they are tackling key environmental challenges on a larger scale, how they are doing a lot of simulation, a lot of modeling work on the level of whole China and on the level also the world, in order to find innovative solutions to reduce the greenhouse gas emission. So it has been amazing to connect with the researchers and the young PhD students passionate about sustainability here, carbon neutrality topics, environmental engineering, the use of timber, and these topics that help a lot in the urban heat island effect mitigation. So also the work has been done here at the College of Environmental Science can be considered one of the top research that you can see worldwide with impact. So also follow their publications if you are interested in this area. I will leave Nankai with a greater understanding of the research shaping the future of environmental engineering. A heartfelt thank you for Professor Zhi Cao, Professor Chu and their research team for their warm welcome and openness. I especially want to thank Shuhao Huo, who joined me in many of my trips, and Zijin Guo for their generous support, guidance and great company throughout my time here. Nankai University is more than a place for learning. I think it's a very big campus with a global ideas and mindset and local innovation coming together. Thank you for joining me in this journey. See you in the next episode.